The fundamental theorem of calculus. We notice that both the definite and the indefinite integrals have the same notation and name. The fundamental theorem of calculus, shortly known as FTOC, links between the two types of integrals. The theorem has two parts. There is some confusion which is part 1 and which is part 2. I will call part 1 the part which is more useful to us, but also generally it is called part 1. Part 1 of the theorem shows how to compute a given definite integral using an antiderivative, but antiderivative is just indefinite integral. And here is finally the theorem, and this is part 1. If f is continuous on the closed interval ab, and capital F is any antiderivative of f, then the integral of fx dx between a and b equals capital F at b minus capital F at a. Let's now see the two steps here. Here is given a definite integral between a and b. The theorem tells us that first of all, we have to find an antiderivative. This can be any antiderivative of f. To find that, obviously, we have to take the integral of fx dx. In the second part, we have to take this specific antiderivative and evaluate this funny thing. This notation means that first you have to substitute b for x, and then you substitute a for x, and then you take the difference. As you can see, the upper limit has to be the first one, and then the lower limit is the next one. And we get f of b minus f of a. Let's note something. The antiderivative of the function f is capital Fx, which is a family of functions. Don't forget the plus c. But if a and b are numbers, then this will be a number. I would like to recall that this has some connection to areas. And if a and b are numbers, this is connected to some area of some sort on the interval AB, which means obviously it is a number. Example, let's find the definite integral of x to the power of 2 minus 2x dx between 1 and 5. In the first step, we have to find first any antiderivative of x to the power of 2 minus 2x. We're going to choose this one. Simplify that. Now we observe the upper limit and the lower limit. Now we have to do the substitution and take the difference. First of all, do not forget the parentheses because we have something minus something. As you can see, I have the antiderivative minus the antiderivative. In the first one, I'm going to replace x by 5. The second one, I'm going to replace x by 1. We will do the algebra. We get 50 over 3 from the first one and negative 2 over 3 from the second one. And we get that everything together is 52 over 3. An example. Let's evaluate the definite integral of square root of x plus 1 over x dx between 1 and e. In step 1, we will find the antiderivative, any antiderivative, so we will take the 1 plus 0. Here is the antiderivative. Don't forget that the antiderivative of 1 over x is ln of x in absolute value. Here's the upper limit, and here's the lower limit. Now we're going to substitute. In the first one, we're going to substitute e for the x. And in the second one, we're going to substitute 1 for the x. Now we just evaluate that. I would like to recall that ln of e is 1 and ln of 1 is 0. So here is what we get from here, and then we get just 2/3 from the second one. And when we put everything together, we get this. And obviously 3 minus 2 is 1, so I'm getting this one. Example. Let's evaluate now the definite integral for x cubed minus 3x to the power of 2 plus 2 dx between -1 and 2. Antiderivative. Here's the upper limit and here's the lower limit. Now we can do the substitution and the difference. In the first one, I have to substitute 2 for the x. In the second one, I'm going to substitute the x by -1. Don't forget the parentheses and the -1. From the first one I get 12, and from the second one I get 0. So the total here is 12. Another example. Let's find the definite integral of e to the x plus 3 dx between -2 and 0. Here's the antiderivative. It can be any one, so I will take again the one that is plus 0. Now I'm going to substitute the upper limit 0, and I get e to the 0 plus 3 times 0. Then I have to substitute -2, and I get e to the -2 plus 3 times -2, and I take the difference. Don't forget parentheses. And I get that. Another example. The integral of secants to the power of 2x dx between 0 and pi over 4. Here's the antiderivative, and here are the limits. Now we will substitute pi over 4, and we get tangent pi over 4. Then we substitute 0, we get tangent of 0, and we take the difference. Tangent of pi over 4 is 1, and tangent of 0 is 0. And we get 1. Example. The integral of 1 over 1 plus x to the power of 2 dx between 0 and 1. The antiderivative is the arctangent of x, and the limits are 1 and 0. We get the arctangent of 1 minus arctangent of 0. And I would like to recall that arctangent of 1 is pi over 4 and arctangent of 0 is 0. And we get that the total is pi over 4. Example. Show that the integral of sine x dx between -pi and pi equals 0. An antiderivative of sine x is negative cosine x. And then we have to substitute the limits. We get negative cosine pi minus cosine of minus pi. Cosine of pi is -1, and cosine of negative pi is also -1, so we get 0. There is also another tricky way to do it. We know that the cosine function is an even function. It means that f of -x equals f of x. This means that cosine of pi equals cosine of negative pi, and that's why negative cosine pi plus cosine of minus pi is 0. Let's look at the picture. We already know what is the connection between areas and the definite integrals. In this case, the definite integral of sine x between negative pi and pi is the area B minus the area A, because it's the area above the x-axis, which is B, minus the area under the x-axis, which is A. And as you can see, the area A equals area B. And because of that, we get that B minus A is 0. In general, if f is an odd function, then the integral of this odd function fx dx between negative a to a is always 0. Pay attention, it's not enough that f is an odd function. Look at the limits of the integral. The lower limit has to be the opposite of the upper limit. Example. Let's find the total area that is enclosed between the graph of y equals sine x and the x-axis on the interval negative pi to pi. The total area now is A plus B. But also because the area A equals B, then this is also 2 times one of the areas, which means it's 2 times the area B, which is the integral of sine x dx between 0 and pi. The antiderivative of sine x is negative cosine x, and the limits are pi and 0. So we get that the total area is 2 times negative cosine pi minus cosine of 0. Cosine of pi is negative 1, and cosine of 0 is 1. And please pay attention, we have minus cosine 0, so it is a plus. And we get that the total area is 4.